good day. Today, we're going to be learning three things: creating parallel circuits, series circuits, and using resistors. Let's start. Before we do our project, we have to prepare the materials or components in Tinkercad-Circuits. So, in the basic components, we need an AA size battery, a button battery, that's a 3-volt battery, and of course, a 9-volt battery. Don't forget also to get at least 4 LED lights, and of course, our resistors. Now we're ready to do our project. When you drag an item or component, you'll notice it's not the right alignment. So you can use the rotate button to actually fix the alignment of the components. Now look for the other items, drag your LED lights, and then maybe you can drag 2 more LED light, and of course you can actually zoom in by pressing the fit to screen button. Now check on the battery terminal. The AA size, the right is positive and the left is negative. The same with the other battery. But in the 9-volt battery, it's reversed. Negative is in the right, positive is in the left. Now let's connect our LED lights using our batteries. You may want to change the color. Red is positive, black is negative. Start simulation, you'll see the light. Then let's wire using the button. Positive, then negative. Let's start simulation. Notice there's a slight error because the power is greater at 3 volts. Stop simulation. Let's wire the 9 volts to the LED light. Start simulation. Notice it did not light up. It did not light up because of the wiring. The terminals are reversed in the 9 volts compared to the other battery. So, notice red in the right. Now, while the other in the 9-volt battery, the positive is in the left. So, we'll reverse the wiring since the terminal is reversed. Start simulation. It works. It lights up. But you notice that the light in the 9-volt battery exploded. Why? There's too much electricity compared to the 1.5-volt battery. So what do? We need something called a resistor. What is a resistor? A resistor controls the flow of electricity from the battery to the LED light. So let's rewire. Let's select and delete one of the wire. But this time, let's connect the battery first to the resistor and then connect it with the light. Start simulation. Notice the battery did not explode because of the resistor. But if you notice, the light with the button has a slight error. So what can we do? We can actually add another resistor to the light. So let's rewire. Delete the wire, drag another resistor, then connect the battery to the resistor and the other part of the resistor to the LED light battery. Let's start simulation. Now, there's no error because the resistor controlled the flow of electricity. Now, before we continue, let's practice how to zoom in and zoom out. Now, using the scroll button of your mouse, you can zoom in and zoom out. Or, you could also use the keyboard. Command or Control plus or Control minus, you'll be able to zoom in and zoom out. Again, let's practice. Scroll, and then you can zoom in. Now, let's start assembling our parallel circuit. For our parallel circuit, we need a power source. That's a 9-volt battery. So rotate. And at least 2 LED lights. So we're going to start with the first LED light. Just drag it there. And we'll make our initial connection. Now, don't forget that we need a resistor. Then connect the resistor to one of the terminal of the battery, and then afterwards connect it with the LED light. Let's start simulation. That's your basic circuit. In order for it to be a parallel one, we're going to add a LED light. Now, a parallel circuit means that both the terminals of the light will be connected to the power source. For example, the positive is still connected to the power source, and then the negative is still connected to the power source. So we're going to connect both of them. Now, if you notice, if you look at the wires, the cathode and anode connection of the second LED light is still directly connected to the terminal of the battery. That's why you call it a parallel circuit. Now, let's assemble a series circuit, and let's see how different it is from a parallel circuit. So, need a battery, still the same. Let's zoom in a little bit. You still need the LED light, but this time our setup is different. So we're just gonna drag the second LED light, and then we will connect the wires. The difference is, in a series, you only connect one wire to the power source, and then connect the other connection to the other LED light. Again, I repeat, you do not connect all the 2 terminals, only one. And then, if you notice, in the third LED, we connect it with a terminal. Notice the difference. We'll start simulation. Notice it's not lighting. Why? Because we have our wire in reverse. So delete, delete. Remember, let's cross because this has a different terminal. Click, connection, play simulation. It works, but notice the bulb exploded because we forgot to put a resistor in the wire. So delete, keyboard, put a resistor, then notice, start simulation, it now lights up. A series is different because if you notice, the wires are on a circle. In other words, only one part of the LED light is connected to the power source. Unlike the parallel wherein 2 parts of the LED light is still connected to the battery terminal. Congratulations! Don't forget to like and subscribe to my page. Thank you!